Hey guys, it's Bill from Linden, Tennessee. So this is going to be, I guess, part one of part two. So this is going to be part two of radiator fabrication and installation video series. I'm not sure if there's going to be a three because this is probably going to take care of it. But anyway, this is going to be, so here I am showing you this thing. Pretty much got it done now. Well, I do have it done now. It's kind of hilarious. So this was, like I told you, this is a Civic radiator, and there was the outlet was here, the drain plug was here, the inlet was over here, and the radiator cap was over there. Well, basically I took I cut every single thing off that was on it originally, plugged it up, and put my own things on it, which is fine, you know, because that's what you do. So this is my new radiator outlet. So as we're sitting, this is like pretend you are we're sitting in the engine bay looking forward. So this is the bottom driver side, and that's the top passenger side. So this is where the coolant comes out, hopefully nice and cooled, comes out, goes to the water pump, goes into the inverter, and then comes back around and goes up into there from the inverter, nice and warm, because the coolant absorbed all the heat from the inverter so that it's not hot anymore. And then it's going to come through here and get cooled off, and then come out here much, much cooler. Then it's going to go into the inverter, and it's going to cool everything off, remove the heat, which is the same thing. I kind of got into a thing about that on one of the Facebook pages. I was telling them how my other radiators didn't have enough capacity to remove all the heat, and he's like, well, that's weird. I thought radiators cool the fluid. And I'm like, well, that's the same. Like, that's the same. Like, there's no such thing as making anything cold. You remove heat. Like, that's just how the physical world works. But I don't know if you believe me or not, but that's how it is. So anyway, this is the radiator on the bench. So I'm going to put this thing in and bolt it in secure, and hopefully for the final time, I've got my, let me find it. Hold please. What do I do with it? Oh, it is. I got my Radiator Vacuum Kit here. I've never used one of these before, but I watched some YouTube videos and it seems pretty self-explanatory. So this here widget, I'm going to have this coolant reservoir up here. I'm going to have this teed in to the return from the inverter. So this will be teed into the return from the inverter, and this will be the way that I fill the system, and it'll be like maybe not an overflow, but a what would it be? An expansion tank. So whenever the coolant does expand, it'll have somewhere to go. And I'll only have this about half full at any given time. So yeah, so I'll put that this here widget, this here dually goes inside that catch can. This will pull a vacuum. I got to run shop air in through this. This part goes right here. You run shop air in through here, and it blows over a Venturi. Or a Venturi is just a restriction in a tube or a hose or something. So if you got a 1/2 inch inside diameter hose, and then you reduce that to say 1/4 inch or something, and then blow air through that at a high volume, a high speed, you have low speed coming into it, and then high speed going through it, and that creates a vacuum. Just how that works. It's not a whole lot different than how an airplane wing works. The air goes real fast over the top of the wing. It goes slow underneath of it. It creates a low pressure, and that's how you fly. That's the way it works. So it creates a low pressure on the top of the wing where the air is flowing fast. So it's as much the wing sucks the airplane up as the outside air pressure pushes the wing up from the bottom. I digress. Anyway, so this thing I'll put on there, and hopefully my compressor has enough air output to make it work and suck this whole system down to a vacuum. And then once it is sucked down to a vacuum, you shut that valve off and it'll hold a vacuum. And then you put this here gizmo on it, stick that into a 5-gallon bucket of coolant, thereabouts, and open the valve back up again, and it magically fills it up, I hope. And I've never used one of these before, but I guess it's the way to do it. And yeah, we'll do it. We'll check it out. So that's what's on the plan. That's what's on the agenda for today. And yeah, I'll see you in a minute. All right, guys, here's an update. So I got this all back together. You can see it's all in there. It's all nice. This is the vacuum bleeder deal. You have to put this in now, and then you put shop air right here. It blows through a venturi, creates a suction. You open the valve, pulls down a vacuum, and pulls a vacuum. And I had it stuck over there. So I pulled a vacuum on the whole system. It actually collapsed the heater hose, you know, the coolant hose, just like it's supposed to do. And then I took the vacuum off of here, and then you put a clear hose that's got this same fitting on it. You put that clear hose in there, and then you open this valve, and it puts coolant in and fills in that vacuum. It didn't work. I don't know if I did it wrong. I probably did it wrong. I did it twice, and if I did it wrong twice, then I'm starting to think it can't possibly be me, or perhaps it's definitely me. I don't know. So I don't really know what to do. But it's not working because there's no coolant flow. Like the pump is cavitating, so I can hear it do that. And I think the pump has some circuitry in it that if it doesn't draw any amperage for so long, it just shuts itself down after, you know, a few minutes, so it doesn't burn itself out, so it doesn't burn its little seals out. I think that's what's happening. So two possibilities. One, I think one thing I'm going to do is I'm going to pull this radiator out, and I'm going to put that drain plug right here at this very high point on the radiator. And that way I can fill this up with coolant. And as long as the coolant level here is higher than the coolant there, then this will just fill the radiator up. It'll also fill the back half of the, well, it'll fill the inverter up, but it could still leave airlocks in there. So I'm not sure really. I think another thing that I may have done wrong, and I did this sort of for simplicity, but this line, right, you know, this line right here comes from the lower radiator mount, and then it, you know, then it comes up with here, and then it goes over to the dimly lit pump. Where is it? That's not the right pump. There, to this dimly lit pump, right, and then goes out this way into the motor and all that other stuff. So if there's any air in this line going up to the radiator, then that air will get into the pump and it won't pump. It'll start cavitating, and that's the end of that. So I got to figure out a way to get that air out of that line. Vacuum's not doing it. I'm not sure what could. I could possibly put like a I'd need to put some valves in here, I think. I need to put some valves in here. Because one thing I could do, like I said, I could weld that drain on the top of the radiator. And then, if I've got, I don't know, if I've got some valves somewhere, then all that coolant would come from the catch tank. It would come through the bottom line here, go through the pump, come around, go into the drive unit, and hopefully fill. I don't know, see, because part of the coolant goes in through this way, it goes up, and it goes around through one of these tubes, and then it goes through a little orifice, and then it crosses over and feeds into the, there's some heat sinks on the other side of this gearbox, and then it goes to the outlet, but it also goes up, and it goes into the rotor, and then it comes out of the rotor, and then goes into the inverter. So one thing I may have to do is move this water pump from back in the back, so it's no longer pulling through this long, hose, and put it up closer to the front, up there. That way it's pulling water directly out of the radiator and pushing it through the rest of the system, because pumps are much better at pushing coolant than they are at pulling it. In fact, it's not a pump. That's sort of a misnomer. It's a circulator. It's not a positive displacement pump like a hydraulic pump or something like that. It's just a circulator. It's a centrifugal circulator. You got to have coolant in it, and then the blades inside the pump spin, and they fling it out the out. And as it's flinging it out the out, it sucks it in the in. But if there's any air, that's it. It's over. Game over. So I may have to do version 3 of this coolant system and put that pump up here. The reason I put it in the back was just really for simplicity, because I got to do like a 180 when it comes on this long pipe. I got to do 180 and then come around and go into the motor. So I put the pump right there, because the pump naturally does a 90-degree turn from the intake to the outtake of the outlet. So, you know, I did that. Now the annoyance of moving the pump way up there is I've got my wires here already. So, I guess one thing I could do, I could take one of them other little pumps, and put it up here, and it would be sort of a booster pump. It would take the coolant directly from the radiator and push it through this bottom line, send it to the rear pump. I don't know. So I'm gonna do like I said first. I'm gonna take this radiator and all that stuff back out again. I'm gonna put that drain line. I'm gonna put that. Where'd it go? Yeah, this little dude, that little guy. So I'm just gonna weld. I'm gonna weld that back on the radiator and put, and that'll be in there. I'll weld it at the top. That way I can at least make sure that the radiator is full, and then and then if I had some sort of an on-off, like a shut-off valve, then I could take a line from the outlet of the pump, take it out until I've got coolant flowing through it with no air in it. And as long as there's a good supply of coolant from the radiator, then the pump will continue to pump and just blow any air out just by sheer volume of liquid. Maybe. I don't know. So that's where we're at right now. I'll talk to you later. All right, guys, welcome back to the journey. So I did like I said. I welded an outlet on that. What I actually said I was going to do is I was going to weld this guy. So that screws into this. Unfortunately, it got a little bit warm, and well, that's the end of that. So I just grabbed an AN fitting, 1/2-inch AN fitting. Just happened to have some of these laying around, as one does, and welded that up here. And when I did that, it occurred to me, I'm like, oh, I've got a better idea. So I needed to figure out a way to get some coolant in here, and I needed to fill it in from the top. Now with that little drain that I was going to put on there, wouldn't have been any way to do that. It would have just bled air out. But in this way, I can put a tube on here, possibly get a suction or get a siphon going from a bucket of coolant, get a siphon going, stick that on there, and let it fill in by suction. All right, and then that'll fill up the radiator. And that'll fill up the radiator, and it'll fill up that bottom radiator hose. And it'll just keep on filling up that radiator hose. And then what I can do is I can come over to my little pump maintenance switch, flip that on, and I think maybe whenever the pump gets some coolant in it, it will start pushing the coolant through. And since this radiator will be full as I can, what I can do then is, so this is the return from the motor. I can put that little plug in the top of that hose, which will keep coolant coming out there, but it's teed off down here, and it comes up this line into my catch can, into my swirl pot, as some people call it. So if that's plugged off and I got the pump going, so the pump's going to pump coolant through, and once it starts coming up into here, then I'll know that the line going to the pump is full, and it's pushing it, at least pushing it through the drive unit. And then at that time, I can switch the pump off, reconnect that back up again, and maybe that will work. I don't know. Now the problem is that this is all going to get spliced together into one big long thing, and nobody will see this until after I've kind of figured this out. So maybe it's a good thing, maybe it's a bad thing, but I won't get any feedback for what I'm doing. So anyway, that's how it's going so far. I'll let you know how it does. All right, guys. Got another update for you. I believe this is going to be the last one. So, last time we talked, I was having a hell of a time with that vacuum pump. I never did get it to work right. I did go in here and weld a little fitting on there, and put had a tube there, and I was with a funnel, and I was filling in antifreeze there, and as it was filling up there, it was going back, and then I turned the motor on, and the antifreeze would come down, and it basically worked. Crib notes. I'm going to give you the crib notes of this. It worked as well as I wanted it to. It wasn't easy, and it certainly wasn't clean. I had antifreeze everywhere, and I mean everywhere. Like I took a big beach towel, and like, I don't know if anybody's been in the military, but I was in the Air Force, and when you're in basic training, everybody has like a cleanup detail. My detail was to be the dust bunny, and that means that you get a wet towel and you roll it up and you crawl on your belly and you go underneath of all the bunks and all the beds and you pick up all the dust and you go around all the posts. And that's what I did. I took a towel and I got on my belly, and I got on a creeper actually, and just went underneath there and sopped it all up, and what a mess. But anyway, yeah, I think we got it going. Previously, when I had this thing running, the pump would just cut out after about 10 minutes or so. And I'm pretty sure that there's some circuitry in there watching the amperage. What am I showing you? Watching the amperage. And if the amperage wasn't within a certain set of parameters, then it would just shut itself off as a self-preservation. And now it's been on for an hour. It's been on for almost an hour now. So I'm pretty sure it's going to work now. I also took this opportunity to plug it in and charge it again. It certainly wasn't empty, but it needed some. And the reason for doing that, of course, is that I need to make sure that the charger is going to stop whenever I want it to stop. And when it's at the top of the charge, I don't have to wait around as long as when it's somewhere else. But so I did that, and that's pretty cool. And let's see what else. Yeah, so I believe I got it. I've got all the air, as far as I can tell, out of the system. There is coolant flow. If you take that off, coolant will trickle out of there. So the radiator is full. This has got probably up to here. I may take a little bit out of that so that this has some expansion in there if it ever needs it. And yeah, man. So I think we got it. What am I gonna do if this doesn't work? I don't know. I haven't got that far. That's how this stuff works. You just tackle problems when they show up, and you can't really plan for any of them. You just do it what you can when you can. Another fun thing that I did yesterday is I got my soft top on. I'm real happy with how it looks. This over here had like this huge gap. There's a big zipper goes all the way down. There was a huge gap between here, and whenever these are cold, they're like they don't fit basically. So what I did is I took a space heater, like one of those ceramic space heaters, and turned that thing on high, set it on the inside, closed the doors and the windows, and just let that thing eat for about 2 hours or so. Got the temperature up to about 80 degrees inside there, almost 100 degrees at one point. And I was able to pull and stretch and grunt and sweat and got it on, and that's awesome. So now I can actually test this thing outside, and if it does work, I can park it outside, and that'll be great. Now, I'm going to confess to being a little bit of a weenie here. When I first had this going, when I first had the coolant system, I used my vacuum bleeder. When I first had it and it was going, I would have liked to take it out to see if it works, but we had snow on the ground, and today it got up to 50 something, so it's a little bit of Alaskan breakup around here. Everything is muddy, and there's slush everywhere, and there's probably salt on the roads. and I didn't want to get dirty. Quite frankly, I just didn't want to get dirty yet, because I know that if for whatever reason this doesn't work, then I'm going to be crawling around under this doggone thing and trying to fix whatever problems it had, and I just didn't want to get dirty. As it turns out, that's a good call, because there wasn't actually any coolant flow. I could have really, really damaged that inverter if it doesn't have coolant circulating through it, like badly damaged. So I'm glad that I didn't take it out for a drive. So as much as I want to drive it and see if it works, I'm gonna wait until it dries off outside, and that's how it's gonna do. What I may do tomorrow, I may put this thing up on jacks, leave the tires and everything on, put it up on jacks, and just put it in drive, and have it driving, spinning the wheels at like 10 miles an hour or something, just sort of sitting there doing it, and it'll build some temperature up in the inverter. And if the temperature in the inverter climbs, then I'll know it didn't work. If it doesn't climb, then I won't know for sure if it didn't work, because it's not actually under a load. So, but yeah, that's probably what I'll do tomorrow. And yeah, so that's where we're at. And thanks for watching. Thanks for sticking with me for this one, and we'll catch you next time.